For USM Anywhere to monitor traffic from your physical network, you'll need to allocate a spare network card on your ESX server to pass the span port or mirrored traffic to the virtual network. We recommend that, at a minimum, you span from the switch connected to your gateway and connect the span port to a spare NIC on your ESX server. You can then associate that spare NIC with a virtual switch. The sensor provides multiple virtual network interfaces that you can use to monitor different segments of your network. It can be used to monitor both physical networks and virtual networks. We recommend connecting each interface to a different vSwitch that mirrors a different subnet within your network. Here we can see we have a number of network adapters, none of which are receiving network data yet from our virtual or physical networks. Moving to the ESX, I've opened the settings of my USM Anywhere VMware Sensor. Here I can see we have 5 network adapters. The first network adapter will be used for management. This means you will give it an IP address that you can use to connect to the sensor and configure it. It will also be used to receive logs from your assets and can also be used to run API calls to access third-party products and for vulnerability scans. The remaining network adapters can be connected to different subnets in your environment to analyze the network traffic passing through those subnets. Note the names of the networks that the sensor is connected to. The first network is called rooted. It will be used for management and not for network analysis. The remaining network cards will be used for network analysis. Moving to the network view, we can see the rooted port group. Our first network card is connected to this port group, which is on vSwitch 0, which in turn is connected to VMNIC 0. We will leave this as it is, as the first network card will not be used to analyze network traffic, as it is for management. The second network card is connected to the VMNet analysis port group, and this is on the same virtual switch as the virtual machines we want to analyze. If we choose properties for this port group, then we can enable promiscuous mode. Enabling promiscuous mode on this port group allows any device connected to this port group to view traffic on the whole switch. So as we've connected a virtual NIC from our sensor to the promiscuous VMNet analysis port group, we can now see all of the traffic passing through the switch, including the virtual machine traffic that's connected to the virtual production port group. Our next virtual switch has no virtual machines connected to it. However, it also has a physical network card, and this physical network card is connected to the physical production network outside of the ESX. You will need to forward all traffic that you wish to analyze to this network adapter. To identify the network adapter, open the physical card's properties, where you can see the PCI slot that the network card is connected to on your server, the type of network card, as well as the MAC address of the network card. Also, you can see what networks are visible to that network card. In order for our sensor to see the network traffic that's being passed from the physical network to this network adapter, we again need to enable promiscuous mode for this physical production port group. Similarly, for our DMZ network, we will be forwarding traffic from the DMZ network to VMNIC 3, and as our sensor is connected to the DMZ port group, we will again need to enable promiscuous mode for that port group. Finally, we have a desktop VLANs virtual switch. The network card connected to this virtual switch is receiving traffic from a number of different VLANs. So not only do we have to enable promiscuous mode for this port group so that we can see the traffic, we also have to configure the port group to accept traffic tagged with any VLAN ID. To do this, we will set a VLAN ID of 4095. This means that this port group will not drop any VLAN traffic regardless of the VLAN ID. An easy way to remember this number is that it is the highest number that you can set. Again, we will need to enable promiscuous mode. Returning to our USM Anywhere screen, we can see which network adapters we're receiving data from and which network adapters we're not receiving data from. Remember, this screen takes 30 seconds to update, so it may take a minute or so for these check marks to become green. Notice that our first network adapter is still showing up as not receiving data. Returning to the ESX, we'll remind ourselves that we've enabled promiscuous mode for the VMnet analysis port group. This will allow us to access the network traffic of all of the devices in virtual production. Notice connected to virtual production, we have vJuice 2 and vJuice 1 and our USM Anywhere sensor node. The USM Anywhere sensor node should be connected to the promiscuous port group in order to see all of the traffic in the virtual production port group, as well as any other traffic on that vSwitch. In this case, the mistake that was made is the sensor was connected to the port group we wanted to analyze, as opposed to the port group where we had enabled promiscuous mode. Returning to the sensor, we can now see that we have all green check marks.